In example 1, we're given two functions, f of x, which I'm going to underline in green, and g of x, which I'm going to underline in blue. And it says state the domain and range of each function. So something that we've gotten really good at this year is graphing. We've done lots and lots and lots of stuff with graphing. So with that green one that I've underlined, well, from grade 10, you probably know that that is a line, or from grade, even grade 10 or grade 9. It's a line with a y-intercept of 1. So that's the picture of that graph. For g of x, maybe you'd feel more comfortable if you rearranged it and put the negative x squared first plus 4. And you could use your transformations to say that's a parabola, flipped over the x-axis, and then shifted 4 units up. 1, 2, 3, 4, going down. So this year, we've gotten really good at graphing, so we have a picture of both those graphs. And it says in the first bullet, state the domain and range of each of those functions. So if I was figuring out my green one, well, since it's a line, I know my domain and range is everything. And then if I look at my parabola, again, my domain is everything. But my range is less than or equal to 4. Thinking back to our first classes at the beginning of the year, and some of you asking, what's domain again? What's range again? And I think by now you're pretty much that you feel like domain and range questions are like common sense, because we have done thousands of them, it feels like. So there's our domain and range of our green and our blue graph. And now in part A, it says we want to sketch each of these graphs and then state the domain and range of those graphs. Now, if we just think graphically, what's going to happen is we're going to do g of x first, which is going to give us that parabola, and then we're going to throw that parabola into the line. And that should cause your brain to have no graph whatsoever appear in your head. So what we're going to do is we're going to find the equation, the explicit equation for the composite function, and see if that equation is something we know how to graph. So f of g of x, what is f of g of x equal to? Well, we always start with composite functions. We start with the inside. And the inside function, g of x, is equal to 4 minus x squared. So I replace g of x with 4 minus x squared. And now I have a 4 minus x squared being put into f of x. And if we think about the rules of f of x says whatever you put in, you just add 1 to it. So if you put in a 4 minus x squared, you will get a 4 minus x squared and add 1 to it. That's the rule for f of x. If I simplify this, I'm going to get a negative x squared plus 5. What does this graph look like? It's a parabola, flipped upside down, shifted up 5 units. Okay? This would not be acceptable on a final exam as a graph. Why? When you provide a sketch, you have to have at least 2 points. Well, I know that my vertex is at 0, 5. If I wanted to find another point, there's a number of different strategies you could use, but I could just plug in a value for x, plug in 1. 1 squared is 1 times the negative is negative 1 plus 5 is 4, and that would give me another point. So there's the sketch. What's the domain and range of this graph? Well, now that we've got our graph, it's easy to see the domain is everything, and the range is y is less than or equal to 5. For B, in B, we want to find f of x. So the inside function first is f of x. F of x is whatever you put in. I'm putting in an x, add 1 to it. And then f of x plus 1 says now we're going to put an x plus 1 in, and we'll need to add 1 to it. So simplifying that, this equation just becomes x plus 2, straight line graph. You know your y-intercept is 0, 2. Add one other point to your graph to complete your sketch, which is negative 2, 0. Or you could pick 1, 3, or whichever points you would like. Domain and range. X can be anything. Y can be anything. Questions for practice. Number 4.